All right, so today we're going to talk about how to graph linear functions by using a table. Okay, so a lot of you guys are more familiar with graphing in slope-intercept form. You probably talked about that last year, but I want to talk about a really important thing, and that is how the x's and the y's relate to each other. I want you to have kind of a deeper understanding of what a linear function is when you're graphing it, and not just say, oh, you do this, this, and this, and then you get a line. Okay? All right, so I want us to solve the equation here. 7 is equal to 2x plus 1. Okay, so if you're going to solve this, you'd probably minus 1 on both sides. And you'd get 6 is equal to 2x, and then you divide by 2 on both sides. So you would get that x is 3. Okay? So x is 3. And there's a little note here. It says when you solve linear equation, when you solve a linear equation with one variable like the one to the left here, there's only one solution. In other words, there's one and only one value of x that makes the equation true. So in this scenario, the only number for x that would make this equation true is if you put a 3 in there. That's what it means to be a solution, right? But now instead of 7 right here, instead of having a 7 right there, what if we put a y there? Okay, so now we're changing that 7 to a y. And now the question is, so they want you to try to find a combination of numbers for x and y that makes this equation true. Okay, so we're trying to find a number that we could plug in for x and a number that we could plug in for y that would make this true. Okay, and the first one that I thought of was if you make y 9 and you make x 4, then this equation will be true. Okay, so if x is 4 and y is 9, then that is true. Okay, but let's think of some more number combinations that would work for this. So I don't know, what if we make x like 0? So if we make x 0, so if you make x 0, you have 2 times 0 plus 1. What would y need to be to make this equation true? Well, 2 times 0 is 0 plus 1. Wouldn't y need to be 1? So if you make x 0 and y 1 in this equation up here, it's true. Okay? Let's do some more. What if we make x 1? Like, we're just going to go down the line here. No pun intended. If you make x 1, so that'll be 2 times 1 plus 1. Like, what would y need to be in order for this to be actually equal? So it'd have to be 2 plus 1. Wouldn't y have to be 3? And then, we just keep going, so on and so forth, right? If x is 2, let me see if I can get in here and just change this. So if you make x 2, then what do you have? You have 4 plus 1. So the y value is 5. The y value would have to be 5 there. Okay, what if we make x 3? So if we make x 3, so we come in and change this. 2 times 3 plus 1 is 6 plus 1. So the y would need to be 7. If x is 4, we already know that y is 9, right? We already did that point. And so on and so forth. Let's do some negatives here. So what if we make x negative 1? So if we make x negative 1, what do we get? So if we do 2 times negative 1 plus 1, that would be negative 2 plus 1. Wouldn't y be negative 1 as well? Okay. How about negative 2? I don't know why I keep erasing this. 2 times negative 2 plus 1. That would give us negative 4 plus 1. That would give us negative 3 for y. Okay, I mean, you can keep doing this. If we plug in negative 3, what do we get? At a certain point, it gets a little boring because you're kind of like, okay, this is plenty of points. Like, I don't need any more points. So let's go ahead and graph this. Okay, so I'm just going to leave the last couple blank because I think you get the idea. So let's graph these points here. So when x is 0, the y value needs to be 1 there. So when x is 0, y is 1. I'm going to graph these with an orange color here. So when x is 0, y is 1. That's that orange point there. When x is 1, y is 3. So when x is 1, y is 3. So that's that point right there. When x is 2, y is 5. When x is 3, y is 7. When x is 4, y is 9. When x is negative 1, y is negative 1. So negative 1, negative 1. and then -2, -3, and then -3, -5. Okay, I know that was a little quick there, but look what happens when we do this. We get a really nice, perfectly straight line here. Okay, and so this is what we call, right here, a linear function. And you might remember from last year, how do you graph these? Typically, you start at 1, and then you go up to right 1, up 2 over 1. Yeah? So if you come look at our graph, look at that. See how we start at 1 here, and then we go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1. So that's how you graphed them last year. But I just want to show you that basically I'm just going to read what we wrote here. When we write an equation with x and y, we get lots of solutions. And technically, they're an infinite amount. Like, we could just go on forever, right? If I do -4 here for x, it's going to be -7 for y. If I do -5 for x, it's going to be -9. Like, we could just do this forever, okay? When we show all the solutions visually by graph, like when you start plotting every single point that's on this, it creates a line. Yeah, so we call functions like this one a linear function. Okay, a line is just a bunch of points or ordered pairs that make the equation true. So what you're seeing here is you're seeing visually with the line here, you're seeing all the points, all the coordinate pairs, all the xy coordinate pairs that make this equation up here true. So that's all a line is. It's just a visual depiction of kind of the reality of this equation being true there. Okay? All right, let's move on to the next page. So definition then, a linear function is just a function that when the input is increased by the same amount repeatedly, the output is increased or decreased by the same amount every time. So when you draw them, a linear function creates a perfectly straight line. So let's look at the table here. It's a lot easier to look at pictures and say, oh yeah, like these are linear, and these two obviously are not linear. But you can tell from a table pretty quickly too. So let's ask ourselves, is this a linear function? To be linear means that if the inputs are going up by the same amount every time, see how they're just going up by 1 here, +1, +1, +1. That means the outputs need to be going up or down by the same amount every time as well. So see how that one's +3, and then 8 to 11's +3, and then 11 to 14's +3. So this is linear. Yes, absolutely. This is linear right here. For this table, at least. Because the outputs are going up by 3 every time, and the inputs are going up by 1 every time. So you actually, by the way, this is the slope here, 3 over 1. Okay, how about this one? So on this one, -2 to -1, -1 to 0, 0 to 1. So we're all going up by +1 over here on the left. What are the outputs doing? So as the inputs are going up by 1, what are the outputs doing? The outputs are going down 2, down 2, down 2. Okay, so yes, this is linear because the outputs are changing the same amount every time based off of the input changes. Okay, how about this one? 4, 5, 6, 7. So those are going up +1 every time. 12 to 9, 9 to 6, 6 to 5. So this is -3, -3, -1. Uh-oh. See how the output, the change in the output was different there? Instead of -3, it was -1. So this is not linear. I don't know what that's going to look like, but it's not going to look linear. Okay, next one, 4 to 6, so 6 to 8, 8 to 10. So we're going up +2 every time here, right? So +2 every time. What are the outputs doing? It's +4, +4, +4. Cool, yep. So this is linear. Even though we're going up 2, that trips people up sometimes. That's fine. As long as the outputs are going up by the same amount every time as well, we're good. How about this one? So 4 to 5, 5 to 6, 6 to 7. So that's all going up +1. -2 to -2 is +0, +0, +0. So what do we think on this one? The answer on this one is yes, this one's linear. What happens on this one is when you graph it, you have your y-axis and your x-axis. This one just kind of looks like this. It just goes flat like this. But it's still a line, right? It's just doesn't go up or down. It's just flat. So okay, cool. How about the pictures? So these are these are pretty easy to see. Like, is this linear right here? This curved thing? No, it's not. It's not a straight line. It's curved. This thing's called a parabola, actually. How about this one? So is this one linear? I would say yes, absolutely. This one also linear, yes. Even though they end, that's fine. They can end. They're still linear. They still have the shape of a line. So yes, 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 and then this one is no. See how it curves? Not linear. Okay? All right. So basically, all we're talking about today is just kind of what a line is and getting you comfortable with the idea of sometimes you're going to have equations here with an x and a y in them, and we're just trying to find different combos of x and y that make it true. So they want you to graph the line 2x plus 3y equals 7 by making a table and plotting ordered pairs. So what we're going to do here is we're going to make a table with x values and y values. And we're just going to try to find different combos of x and y that make this true. And then we're going to plot those points. Okay? So this is, in my opinion, one of the easiest ways to draw a line, actually. You can get it in like slope-intercept form. Y equals, something x plus something. And that's nice, but this is also a great method too. So, all right. So let's see. So if we make x, oh boy. Okay, so we got to pick these carefully here. So 2x, so whatever x we put in, we got to put it in there, and then whatever y we put in, we're going to put it there. So let's try to pick our numbers carefully here. So if we let x be 1, and let's think about this here. So you're going to have 2 times 1, that's 2, plus 3 times something is equal to 7. So you're going to have 2 plus 3 times a number is equal to 7. And the question is, like, what number needs to go there? And we can get a number there, but it's not a whole number. Right? Like if you plug in 1, what would happen? If you plug in a 1 here, what would happen? So you'd have 2 plus 3 times 1, that's not 7. What if you plug a 2 in for the y? Then you'd have 2 plus 3 times 2, that'd be 6. So this would be 8 right here, right? So that's not 7. So this is going to be a decimal in there. So let's not do that. So 1's probably not a good number to plug in there. Let's try 2 here. So if we plug in a 2 there, we get 4 plus 3 times something is equal to 7. Is there a number we could plug in here nicely that would get us there? Yeah, if you plug a 1 in where that orange question mark is, you're good. So I would say one combo of numbers that works is when x is 2 and then the y value is 1 there. So when x is 2, y is 1, that makes this equation right here true. So okay, good. All right. So let's write those in, and then let's erase these. So let's get rid of those, and let's try another combo here. So if we try 3 for x, that would get us 6 plus 3 times something is equal to 7. That's not great. What if we tried 4? So that'd be 8 plus 3 times something gives us 7. That's not working really well either, right? That would be a fraction in there. How about 5? Let's try 5. So that would give us 10 plus 3 times something is equal to 7. And I hope I'm not moving too quickly here, but this right here, we could throw in a number there for that orange question mark, right? So like what could we put in there that would make this work here? I would say if we plug in a -1, that would be good. So if we do a 5 here for x, we can get a -1 in here for the y value. Okay? So if we do a 5 for x there, and then we can throw a -1 in there. If you do 3 times -1, that would give you -3. So you'd have 10 minus 3 is equal to 7. So that works. Okay? Okay, so what you have over here, if you look, is you have a couple points, right? So you have a couple ordered pairs. So you have 2 +1. That's one ordered pair. Another ordered pair is 5, -1. And here's the beautiful thing about graphing with a table like this. You literally only need 2 points to be able to draw a line, right? Once you have 2 points, you have a line. So we could come over here. I mean, if you really want to, if you play around with it for a while, you would realize that if you make x 8, you can make y -3, and that works. But, we only need 2 points. So let's go ahead and graph these. So we're going to graph 2, comma 1 and 5, comma negative 1. Okay, so 2, comma 1. So we'll put these in orange here. So 2, comma 1 and 5, comma negative 1. And so it looks to me like if you come look at this, like if you go down 2, you're going to go right 3. So down 2, right 3 on this line, which actually, if you look at the other point we found, 8, negative 3, let's go plot that. See where I wrote 8 for x, negative 3 for y? Let's go plot that. So 8, negative 3 would be right here. And then look at that. See how we're going down 2, right 3? So once you get a couple points on your line, the rest of them you can kind of just figure out like, oh, hey, I'm going to go down 2 over 3. From here, we can go up 2, left 3. So I bet if we plugged in negative 1 for x, we would get 3 for y. And, you can, so on and so forth. You can just keep doing this. So this is a nice little trick here. And we are good to go. There's your line, and that's it. So that's all they wanted us to do, right? Yeah, graph the line by making a table and plotting ordered pairs. Okay? All right. Well, that's how you graph by making a table.